Procedure. Measurement of the apparent loss in weight of solid block in tap water. Suspend a spring balance from an iron stand or from a hook fixed to a rigid support. Check the balance for zero error and note it down. Suspend the solid metal block from the spring balance with the help of a string. Read position of the pointer on the scale. Note it down. This gives the weight of the block in the air. Fill a Eureka can, a glass or metallic container with a spout, with tap water until it starts overflowing. When the dripping of water from the spout stops, place an empty measuring cylinder under the spout. Gently lift the Eureka can and place it on the wooden block so that the solid block gets completely submerged under the tap water. Collect the displaced tap water into the measuring jar. Note down the reading on the spring balance. The reading on the balance gives the weight of the block when immersed in tap water. Read level of water in the measuring jar and record its volume. This gives volume of the tap water displaced by the solid block. Taking the density of tap water as 1 gram per ml, we can calculate mass and weight of the displaced tap water. Measurement of loss in weight of the solid block in salt solution. Repeat the experiment as reported above by taking salt solution in place of tap water. To determine the density of salt solution, weigh accurately a dry beaker, 100 ml capacity on a physical balance. Pipette out 50 ml of the salt solution into the beaker and weigh it on the same physical balance. Mass of 50 ml of salt solution can be obtained from the above weighings. Then, density of salt solution is equal to mass of salt solution taken in beaker in gram upon 50 ml. Calculations. Apparent loss in weight of solid block in tap water is equal to gram force. Volume of tap water displaced by the solid block is equal to milliliter. Density of tap water taken from literature is equal to 1.0 gram per milliliter. So, mass of tap water displaced by the solid block is equal to mean value into density is equal to V2 minus V1 ml into 1.0 gram per ml. Weight of the tap water displaced by the solid block is equal to gram force. Apparent loss in weight of solid block in salt solution is equal to gram force. Mean value of salt solution displaced by the solid block is equal to milliliter. Density of the salt solution as obtained experimentally, rho, is equal to gram per milliliter. So, mass of the salt solution displaced by the solid block is equal to mean volume into density is equal to gram, and weight of the salt solution displaced by the solid block is equal to gram force. Results. From the result obtained, we see apparent loss in weight of solid block in tap water is equal to weight of the tap water displaced by the solid block. Apparent loss in weight of solid block in common salt solution is equal to weight of the common salt solution displaced by the solid block. Apparent loss in weight of solid block when dipped in salt solution is more than apparent loss in weight of solid block when dipped in tap water. Conclusions. From the results obtained, the following conclusions are drawn. The apparent loss in weight of a body when placed in a liquid is equal to the weight of the solid displaced by the body. If the same body is immersed completely in two different liquids, the apparent loss in its weight is more in the denser liquid. The liquid having higher density is called denser. Precautions. The pointer of the spring balances should move freely across the scale. The solid block, when immersed in water, should not touch the sides or bottom of the Eureka can. The Eureka can should be placed on a horizontal surface.